Hello everyone, welcome to the lecture of Object-Oriented Software Design. In this lecture, you will come to know about the open-closed principle. So let us look at that now. In the context, this is our outline. The outline is what is open-closed principle and why do we need to learn this principle. You know, especially when we learn something new, two questions arises in our mind. The first one is what is it, and the second one is why do we need to learn this? Why do we need to learn this? So therefore, in the context, this is our outline, and the lecture is delineated in the context of these two questions. Okay, so let us move on. You see a code snippet here, right? Especially I will explain the principle and why do we need to learn this principle with the help of this code segment. Okay, so first let us look at the code segment. You can see that we have a class called Spanish, we have another class called Chinese, and we have one more class called translator. If you look at carefully, you will find that in Spanish class and in Chinese class we have same method name, same method. Okay, same method. But the Spanish class, the translate method in Spanish class is showing the output like this: English hello is hola in Spanish, and the translate method in Chinese class is showing English hello is ni hao in Chinese. Especially this is a translator like Google Translator. Okay, uh, this is, we can consider this is our main class or the central class. The translator class is the main class or the central class. So we will pass text to it like hello or any other text you like. Then this translate to method will call translate method of Spanish and Chinese class in such a way that it will show the translation in Chinese and in Spanish accordingly. Okay, well, for this you can see that the output is like this: English hello is hola in Spanish and English hello is ni hao in Chinese. Okay, so this is the story. If you have any confusion, you can pause the video and think a bit, and after that we can move on to the next slide. Okay, uh, one more thing that I want to tell before moving on to the next slide, I would like to share with you that I am going to implement this story or this coding scenario in the different languages such as Java, C++, and Python, and I will explain the open close principle with this implementation. Okay, and the language or the language that you are proficient, you can look at that example. That means I am saying that you can look at the Java implementation or C++ implementation or Python implementation, the one you feel comfortable. Okay, so first I'm going to implement this scenario in Java programming. Okay, so let us see that. First is Java. So the class Spanish you can see here. Okay, and default text is hello. I'm directly passing hello text, If you want, you can change any other text you like. Now you see that you know about this, so I should not talk too much. So translate method, it is translating or showing the output like this: English, uh, hello is hola in Spanish. Similarly, you can see the implementation of Chinese class in this way. And the English hello is ni hao in Chinese. Okay, so now we can see the implementation of the translator class. You can see here that this is the translator class, and we know that the translator class will call the specific translate method of from the specific Chinese or Spanish class, right? So for this we need two objects for the two classes, okay, for the Spanish class and for the Chinese class, okay. And we need to initialize the objects. For this I am using a constructor here. Okay, I have included a constructor here and initializing the two objects of the two classes. Okay, you can see here of the two classes of Spanish. Sorry, I should say in this way of Spanish and the Chinese class of Spanish and the Chinese class. Now you can look at the bottom. The translate to class is implementing sorry, I should tell in this way, is calling the translate method of Spanish class and translate method of Chinese class uh, accordingly in this way, one after another, one after another in this way. So this way we are going to implement the main class or the central class in this way, and that is calling the specific translation API from the specific class. Okay, that is the point. Now you can see the main method, or okay, or user interface. I have given the name as the test translator. You can give any other name the way you like. Okay. Now you see the text is hello. I told you before that I am passing a default text hello, and these are the objects initialization for Spanish class and object initialization for Chinese class. Now you can see that I am going to going to initialize the two objects, these two objects, the Spanish objects and the Chinese objects, by this call, by this translator call. And finally you are calling the translate to method, and you are getting the translation in Spanish and in Chinese. Okay, so this way the example works. So if if you are proficient in Java, then you can look at this example, and if you are not feeling comfortable in Java, or if you are not comfortable in Java, then you can look at the C++ implementation. Okay. You can see here C++ implementation is similar like the Java here, like the Java. I should not say similar, but in the context of this example, it is similar. You can see that public, we had public here, like this public in this way, but here it is in this way. So public void translate, and now you are directly passing the default text hello in this way. Okay, in this way, that is the difference. And you are printing hello here, and it is the translation in Spanish. Now you can look at the Chinese class, and if you look at here, you can see that the translation is similar as in Java. Sorry, the implementation is similar as in Java. So this way our Chinese class and the Spanish class is implemented in C++. And now we can see the translator. We can look at the translator class. Okay, so the translator class here is almost, it is almost similar as in Java, similar to Java. The implementation is almost similar, right? So I should not talk much. Only the difference is, let me show you, only the difference is here in this line. Okay, this line. no, no, no other big difference, right? So now we can look at the main method main method definition or implementation, whatever you say. So this also very similar and very simple. This is the default text. If you want, you can change it. Now this is the object for a Spanish class, this is the object for Chinese class, and this is the constructor that is going to initialize the Spanish object and the Chinese object. Okay, so now you are calling the translate to method in the center translator class. That means this method. I am talking too much, so you can look at this one. Okay, so this is very simple. So if you feel comfortable in Java or C++, you can look at any of this example. And if you are not well experienced in Java or C++, then you can look at the Python implementation. You can see it's very simple. So this is the Spanish class, this is the translate method implementation, and this is the default text, and this is the output, or I can say the translation. This is the translation. Okay. The next is the Chinese class implementation. So very simple, right? Okay, so this way we can implement the classes in Python. Now we can look at the implementation of the translator class. Okay. So you can look at here class translator. So what it is doing, as before in Java and C++, you can see that we are going to initialize two objects, one for Spanish class and one for Chinese class. Okay. Next, it is the implementation of the translate to, and you are passing the default text hello, and it is calling the translate method from the specific class, that means from the Spanish class and from the Chinese class. And now you are mainly doing this part we had in the main method in Java and, and C++. Very simple, right? Okay, so this you can consider as the Google translator. Okay, this is the translator is the Google translator, and when you are selecting a language like Spanish or Chinese, then this Spanish and Chinese is showing the translation. Okay, like this. So uh, so this is the implementation of the code snippet that I showed you early in the first. I can say in the third slide. I can say I can say it's fine that I can say you understand it. I hope you have understood it. Uh, if you have any confusion, you can look at the fundamentals of the classes in Python or C++ or Java and or Java. So now I want to mainly extend this code segment. That means suppose we need to add one more language, like the before we had Spanish and Chinese. Now suppose we want to include Portuguese or any other languages. Okay, so uh, how can we do that? Okay, how can we do that? We can see extending the code segment. Suppose we need to add a new class for a new language such as Bengali. Mainly this is my language. I speak in this language, so for this I introduce to you. Sorry, I have introduced to you. This is my language, Bengali. So now we can see the updated code with this extension. Okay, we can see the updated code with this extension. And now you see the simple Bengali. We can create a class in Java, or we can create a class Bengali in C++ or in Python in this way. So as you did before. Okay, that I should not talk about this too much. I should not talk too much about this. Now you can see the modification in the translator class due to this extension. I said the modification in the translator class due to this extension. First I am saying extension. Let me tell. Extending the course segment, that means extending a new class or new module. Due to this new module, we have maybe this extension. Okay. Now, due to this new extension, we can have, I should not say we can have, we may have some modification in the translator class. So let us look at that. First in Java. So extension in Java, you see that we need to have the following adjustment. What are the adjustments? Added one more object in translator class. Okay, you can see. Or added one more object in translator class. This one. Next, changed the constructor code. You can see that I have one change here in the constructor code and one more change here in the constructor code. These two. Uh, Next one, you can see that in method, this one, in method translate to, added code to make a call for calling the translate method in the Bengali class. This one, added code to make a call for calling the translate method in the Bengali class. Okay, so this is the implement extension modification in Java. Now we can look at the main method in Java. So this one, I have added one more object and the constructor has been modified, so the new call will be like this. So this is the implementation in Java. Now you can look at the implementation in C++. Similar, you can see added one more object here and changed the constructor, these two changes in the constructor, and added call, added a new call, okay, for calling the translate method in the Bengali class. Okay, and now we can look at the main method implementation. Very similar and very simple. You can see this. So and the constructor also has been modified. Okay, so this way it is working. Now we can look at the implementation in Python. So similar, we have added one more object here and one more call here. So this is the way it is working. So now you saw that when we are extending, we are mainly modifying the main class or the central class, right? Like here. So if we add one more class, that means we need to add one more object here and we need to make one more call here, right? So every time we need to modify the main class or the central class, right? So for this I have one question to you, and I want to ask one question to you. The question is, you can look at that. Yeah, the question is like this: what do you think? Is this a good design? Yeah, it is a very good design. Do you think that? Or I can say the way I have shown the implementation, is it good? You can pause the video and think a bit. Okay. Okay, so let me talk a bit now. I feel that this is not a very good design. I feel that it is not a very good design. The way I have implemented it is not a very good way, and I feel there is a issue with this design. There is a very big, I can say very big issue with this design. And what is the issue? That is another point. I said there is a issue with this design, and then we need to know what is the issue, right? So let us look at that. Let us look at that. In general, the design that I have shown to you, uh, it is not open for extension. What is the meaning of it? Uh, I'm telling in details to you now. In particular, in particular, there is very high dependability among the modules. In other words, mainly I am saying initially I told that the design is not open for extension. Now I am saying that there is very high dependability among the modules. Now again I am saying that especially what we saw in the implementation, especially we saw that changes, if we do any change, okay, if we do any change in one place, it requires changes somewhere else, right? So I am telling the story again. In general, this design is not open for extension. In particular, there is very high dependability among the modules. We can present this sentence in little bit different way. So the changes in one place require changes in somewhere else. You saw that. Let me go back. So like this. Initially we had only maybe I can show it from here. Okay. Initially, sorry. Uh, Initially we had only the two class, the Spanish class and the Chinese class. So when we have uh, mainly added a new class, then we need to modify in another class, right? Like the translator, we are going to modify in the translator class. One modification is here and another modification is here, right? So what can I say again? Changes in one place require changes somewhere else, right? So mainly in this case, what I can say that when there are interdependencies among the modules, then there is coupling among the modules, like the husband wife. Okay, we are depending on each other, so we have interdependencies. Okay, so similar to that scenario, when there are interdependencies among the modules, then there is coupling among the modules. Okay, there is coupling among the modules, or we can say coupling occurs in this implementation. Okay, or we can say coupling occurs in this implementation. So finally, I want to say that in our implementation, we have coupling. Okay, and it is not our objective. We should not have coupling because due to coupling, changes in one place require changes in somewhere else, right? So if it is not our objective, then what is our objective? We can look at this now. Look at this now. Especially our objective is a class or a module or a function or a method should be open for extension and closed for modification. You can look at this sentence here. So it will mainly you will be able to capture the view in a broader sense or in a detailed manner, or I can say in a great detail. So you can look at here. Once we have written a class or module or a function, it should not be modified again and again over time. Okay, that you saw a little bit earlier, that the module or class was going to be modified again and again, right? Okay, so that is the one point. The another point is that it should be open for extension. It should be open for extension. It should not be modified. However, it should be open for extension. So why? You can look at the third point, why it should be like this. if we modify a class or a module over and over, it will require testing efforts and time over and over. So you can say time and money it will cost. Okay, why? Because it may cause, you can see that it may have functional issues, logical issues, okay, and some other issues also. Some other issues may be if we have a class in binary form, it need be recompiled. Okay, so our objective is a class, a module, or a function or a method should be open for extension and closed for modification. Okay, and this is called the open closed principle. Okay, and this is called the open closed principle. So in object oriented design, I can say in object oriented software design, we need to ensure or adopt open closed principle so that a class or module or a function can be extended without any modification in any other places. Okay, especially what I want to say, especially we need to eliminate or reduce or remove the interdependability or coupling among the modules. Okay, we need to remove or eliminate or reduce the interdependability or coupling among the modules. Okay, and that is our objective. Okay, if we want to really ensure the open closed principle, or if we want to adopt the open closed principle, that means we need to remove, eliminate, or reduce the interdependability or coupling among the modules. Okay, so let us see how can we do that. Let us see how can we do that. So how to reduce the coupling? You can look at here. If you want to reduce the coupling in your Java implementation, okay, then you can do this way using an interface with an abstract method, or in your C++, okay, or I can say the object oriented software design using C++, or object oriented software design using Java. Okay, so in C++ using an abstract class with a pure virtual function. Okay, and in Python using an abstract class with an abstract method, especially if you mainly uh, pay attention carefully what this what it is saying. That means what I said here in these statements, it is especially telling us to adopt dynamic binding to reduce the coupling, or I can say it is especially telling us to follow or implement the scenario using runtime polymorphism. Okay, so let us see the implementation using implementation following in this way, and we can see how we can reduce the coupling or interdependability among the modules. Okay, so let us look at that now. First, we can see the implementation in Java as before. You can see that we have the this one, the interface with an abstract method. So we have language interface here. Since Spanish and Chinese, these are languages, so for this we have I created an interface called language, and we have the abstract method translate, and you can see the Spanish and Chinese class is implementing the translate method of the interface in their own way. Okay, we know that Java interface works in this way, and the class that implements the interface, it implements or defines its abstract method, right? So now we can look at the implementation of the main or the central translator class. You can see that here we have very simple implementation and only one call of the translate method. And if you let me talk about this a little bit later. If you go to the main implementation of the main method, and then you can see that in the translate to method we are passing the object of Spanish class, uh, and we are passing the object of Chinese class separately in this way. Okay, so uh, now you can see when we call, suppose this first translate to by the Spanish object, then this this object, the language lang object, it will become the Spanish object and it will call the translate API from the Spanish class. Similarly, when we will pass the Chinese object to the translate to method, and then sorry please, uh, then this lang object will become the Chinese object and it will call the translate API or the translate method from the Chinese class, and in this way it will work for any number of classes that you want to add in this implementation. Okay, so this is the simplicity. This is the simplicity of this implementation. So as many modules or classes we add, we don't need to do any modification in the translator class or in any other or I should say in the main or in the central class. Okay, that you saw, that you can see here. Okay, and now we can see the implementation in C++. So in C++ we have using an abstract class with a pure virtual function. So the abstract class, you can see language, and the pure virtual function this one. And as in Java, you can see the implementation of the Spanish class and the Chinese class. I think I don't need to tell it in details. In details, I know you know about this. Now, if you don't have if you don't have good knowledge in C++, or if you are not proficient in C++, then you can look at the Python example, okay, or Java example. You can choose the specific one you feel comfortable. Now we can look at the implementation of the translator class and the main method. Let me move. So here you see, as in the Java implementation it is similar. So this is the call and we are passing the object here, like that means the object, sorry, the pointer to the Spanish object and the pointer to the Chinese object here. This one I should cross here because I have marked a lot. So so as in Java implementation, it will work in the similar way. So one call is, so I should not say one call. So this one line is enough for any number of calls or for any number of classes or modules that you have in your implementation. Okay, or you can add or extend any kind number of modules anytime, then we don't need to modify this translator class. Okay, that is the point. Now you can see the implementation in Python. So abstract class with an abstract method, you can write down using a class and an abstract method, that is also fine. Okay, so now you can see that this is the abstract class, and this is the abstract method as before. And now you can see that this is the Spanish class. It is mainly implementing the translate class of the language class. Similarly, the Chinese class also implementing the translate class of the language class. That means they are implementing in their own way as before. So, and it's very simple. You can see it's very simple. Now we can look at the implementation of the translator class. You can see you are passing the object to the translate to method as before as in C++ and in Java, and you are going to mainly call the specific translate API or method from the specific class, or I can say a specific language class. And you can see that how you are mainly doing this. You can say this part is the implementation of the main method in Java and C++. Mainly this is the call that you can see here, this line. So you are passing the specific language object. So first it is Spanish, next it is Chinese that you have initialized in this line. Okay, so in this way you are calling the specific translate API for your implementation, and it is working very finest manner. So now we don't need to do any modification due to the extension in one place. Okay, so there is no changes required due to the modification, or I should say this, there is no changes due to the extension of any module, or I can say if we add any module, then we don't need to do any modification in any other modules. Okay, so if we add any new module, then we don't need to add we don't need to do any modification in any other modules. Okay, that is the point. So that's all about the open close principle. I hope that it has answered the first two questions that were asked initially, that what is open close principle. Sorry please. So what is open close principle? A class or a module or a function should be open for extension but closed for modification. And why do we need to learn this? If we learn this, then we can come to know how to adopt or how to ensure the open close principle in our implementation. Finally, that will ensure that there will be no coupling, or I can say there will be no interdependability among the modules. Okay, that is the point. Uh, one point that I would like to share with you that the sample code that I used in this lecture is shared at GitHub, and the link is given in the video description below. You can check out from there. Uh, so my point is that if you want to my one more point that I want to share with you, if you want to know more details about this principle, you can look at the references in the next slide. This is the this is the references. Okay, that if you want to know more about this principle, then you can look at these references. Now you can see the content of the next lecture, uh, like this one. What I want to say, I want to say that you saw that due to the poor coding or poor design, we will have coupling among the modules, right? So note that this is not the only scenario that we may encounter coupling or tight coupling among the modules. What I am saying, this is not the only scenario that we may encounter coupling or tight coupling among the modules. There are a lot of other scenarios that we may encounter coupling or tight coupling scenarios. Okay, so we need to know the different types of coupling, right? So we need to know the different types of coupling so that we can get rid of these issues. Okay, and especially in the next lecture, you will come to know about this in a greater detail. In the meantime, if you have any questions, then you can write down in the comment section, and I'll get back to you. Yes, so today no more. See you in the next lecture. Thank you very much for your patience. Have a nice day. Take care. Thank you. See you.